10 million gallons of ultra-pure rinse water get used and dumped every day in fabs. If we can save even 5% of that single-use rinse, we're talking hundreds of thousands of gallons of fresh water saved per day. Fabs do recycle water today, but mostly in big centralized plants that treat huge mixed streams the same way. They rarely know in real time how dirty is this exact stream and where else could it be safely used.
That's the gap AquaLoop fills. Instead of one big wasteful drain, we drop smart sensing tanks right next to the processes and let them decide where each liter should go. Water from this tool hits the sensing tank. We measure turbidity, purity, temperature, pH, and we sort that batch into 3 buckets. Clean enough for high-grade reuse, good enough for utility loops such as cooling, or too dirty and we use it for recycling. From there, we drive these valves automatically. This is our simulated sensing tank. It uses real-time data to visualize what is actually happening right here on this table. Used water flows through the sensing tank and gets routed into one of 3 destination tanks: high-grade reuse, utility loop, or treatment. As the reading come in, the water level from the sensing tank moves and one of these 3 pipes lights up and shows a real animated flow.
Now here's the physical version on the table. This is our sensing tank. Down in the water we have got turbidity and TDS sensors and probes for temperature and pH. Downstream we have got 3 outlets we can open based on the output from a fine-tuned ML model that was trained to have 92.8% accuracy. We start with distilled water. Right now the system thinks this batch is at minimum, which is good enough for high-grade reuse, so the reuse valve opens.
This is water we got from the Olentangy River. This water is clearly more contaminated than distilled water, and as we add this to the sensing tank, every metric rises: turbidity, TDS, and pH. As soon as we cross our thresholds, the ML model reads this data, decides the quality of the water, and the class flips to max. The first outlet closes and the treatment outlet opens instead. And on the UI, the flow shifts from the treatment tank and the water is routed to our filtration system. We originally tried to run the ML model directly on the Raspberry Pi and found that with our timeline and sensor noise, it just wasn't accurate or as predictable as we wanted, so we pivoted. What we chose instead was a rule-based classifier on the Arduino for safe deterministic control, and we trained a random forest and parallel SVM on a 4,000 sample Kaggle water quality dataset. That ML sidecar runs offline and in our analytics views, letting AquaLoop simulate a more production-ready monitoring stack without risking flaky decisions during the demo.
Last thing we'll show is what that means when you stop looking at just one batch. On our analytics view, we track per process: how much water came into the sensing tank, how much volume ended up in each outlet, high grade, utility, treatment, and from that, a reuse percentage and a rough gallons saved. Our sensors are outputting data every second to our dashboard. This data is then stored and can be tracked over various timelines.
Industry roadmaps say that fabs can get around 60% recovery just by being smarter about the stream routing. AquaLoop is a modular way to actually do that. You drop these sensing tanks next to critical process families, we sense, classify, route, and prove it all with live data. In the future, we see multiple AquaLoop stations duplicated across a fab, helping push recycling rates up and waste down. We're Munchkins, this is AquaLoop, and we'd love to talk to you about how you'd plug this into your new fab.